Hey everyone, my name is Nazar and I'm starting this channel to teach software development and share what I've learned as a developer. I'm very excited to share this knowledge with you and I hope it make you a real cool developer with my help. It will be a big journey because I'm not a native speaker and also not a professional teacher, but I have 13 years of experience and have master degree in computer science. Also, I've been working as a senior full-stack developer in a web stack with Java, JavaScript, TypeScript, PHP and other languages, and I build enterprise-level applications. At the same time, I'm just a regular guy from a small town in Ukraine who managed to build a career in software development. While living through the daily error alerts, I want to create something useful for you. My English is far from perfect, but that may actually be an advantage, because my vocabulary is not large enough to bore you under endless fluff. The market is flooded with courses promising that you will learn a programming language in 3 months and immediately land a huge salary. At the same time, we are already living in AI era. Almost anyone can use AI tools to build a prototype, test an idea or validate a concept. But prototypes are not the same as a scalable software. Sooner or later, companies still need a real specialist and experienced engineers. Unfortunately, many people enter the profession through the shallow, fast-track courses without learning the fundamentals. My course does not promise a quick start. It begins with the foundations of computer science, the kind that have barely changed in decades. It will be really light and quick because this knowledge is not something what you can use in practice actually, but this is a real good base to understand how people create a CPU and personal PC. My goal is to give you the most important computer science foundations without unnecessary academic fluff. We will spend a month or two, I'm just kidding. We will spend a couple of hours understanding black box we call a processor. After the apocalypse, you may even be able to build one in your garage using light bulbs and batteries. When I started studying programming, I could write loops and functions, but I didn't really understand why they worked or why programming languages were designed that way. I understood those things much later, after reading books and already working as a developer. Had I learned that fundamentals earlier, I believe I would have progressed much faster. More importantly, you will understand how we arrived at modern computers and why things work the way they do, not just that they work. The course is divided into 3 parts. The part 1 is the hardware and number systems. We will explore number systems, binary logic and basic of computer hardware. Using Logisim, we will build simple devices such as an adder, CPU registers and memory. We will also look at how a processor, memory and operation system works together when they run your programs. It is not something what you need to memorize, it is just for you clear understanding how the hardware works and how people create the first program language. I'm not a hardware engineer, but I share everything what I know and in my opinion it will be a good base for the real engineers. Part 2 is the first programming language, algorithms and data structure. Our first language will be C++. Wait, don't leave. We are not going to learn all of C++. We will focus on the basics, syntax, memory, and the key algorithms and data structures that every serious engineer should understand. Why do we start with C++? Many A-level games and game engines are written in C++. Important part of the Java Virtual Machine, Node.js, web browsers, databases, and many other tools are also implemented in C or C++. C++ also teaches you concepts that many modern languages hide from you, like memory, pointers, object lifetime, data structures, and performance. On top of that, many popular languages use a C-style syntax. Once you understand C++, languages such as Java, C# and JavaScript will feel much more familiar, and it will be easy to learn another high-level language and you will understand why people create high-level language, because C++ has a lot of pain. Also, in AI era, a lot of code will be generated by AI and C or C++ save you energy also. Part 3 it's a modern software development, AI and DevOps. We will cover TCP, UDP, HTTP and how applications communicate locally and across the internet. We will explore the modern web stack and the languages like Java and JavaScript, databases, deployments, log, monitoring, DevOps, AI tools, and architectural ideas such as domain-driven design and CQRS, and another buzzword what you need to understand to have a good job. Because modern software development is not only about writing code, it is also about understanding why your service stopped responding, why the database spent 15 seconds thinking about one query, why the deployment failed, and why the logs look like the server took it personal. Knowing only one language is not enough. Over time you will probably learn several technology anyway. The fundamentals will make that process much easier. Later, you will be able to choose your own direction, like a back-end, front-end, embedded system, DevOps, AI, architecture, drones, robotic, or something else. Just don't try to become all of them in one evening. That is a great way to become exhausted before learning anything. I hope this course becomes a solid foundation for your next steps. And if I manage to figure all of this out without a magic wand, a secret programming guild, or an uncle working at Google, then so can you. Let's go!